Sige. We have here for chapter 5, the normal distribution. Before we can really identify what specific inferential statistical tool are we going to use to process the collected data in research, we have to make sure first that number one, we know that we know or we can identify that type of data that we have gathered, whether the data is nominal, ordinal, or scale. Yung scale, it can be ratio or interval, but nevertheless, since they overlap with each other, we can just combine the two of them. And then another thing that we need to consider in finally deciding into what statistical tool are we going to use is itong types of frequency distribution. Okay? So actually, we don't need to really make a graph of the collected data, especially if our data is like more than 100. Mahirap na yun siya i-graph. But nevertheless, ituturo ko sa inyo na nag-exist itong normal distribution or itong frequency distribution and ano yung kanyang importance sa statistics. Now, ito yung types. We have 3 types of frequency distribution. The negatively skewed, normal distribution or normal no skew ito. And then lastly, we have the positive skewed. So ano itong graph na to? This one is the graph of the collected data. So you have here on this side the frequency, and the y-axis is the frequency, and then on the x-axis will be the scores. Okay? The scores ito dito, or kung male or female ba siya, but anything that we measure, dito siya mahuhulog sa x-axis. And then again, yung frequency will be on the y-axis. So for example, we have 100 data. We will be going to make a graph and see what type of frequency distribution can we get. Itong negatively skewed, as you can see, you have here a tail that is located on the left side, and then a peak that is located on the right side. Okay? Nandito yung peak niya sa right side. This one, this negatively skewed is like yung kanyang tail is on the negative direction. So meron kang mga data here na medyo maliit, nag-e-exist sila dito. Merong mga data dito na konti lang yung frequency. Tapos yung peak natin, yung may pinakamadaming frequency, nandito sa right side. That's, again, negatively skewed the set of data. And then we have here the normal distribution at the center. So when you say normal distribution, we have here a normal curve, and the curve class has a perfect symmetrical distribution that if we separate it or lalagyan natin siya ng hati, the right side and the left side will be a mirror image of each other. And in this case, you will have the same mean, median, and mode. So that is the reason why you will really see the peak of the distribution at the center. Okay? And then the last type of frequency distribution is the positively skewed distribution, wherein there is a positive direction here. You will have your peak on the left side and you will have a tail on the right side. So you will have data that is located on this right side, and medyo konti sila. Meron kang data na nag-exist on the right side of the curve pero konti lang sila, so you will have a tail there. Okay? Now let's talk about each one of them. We have, again, the first one, normal distribution. So for normal distribution, we have here a perfectly symmetrical curve, and that the right-hand side of the graph and the left side are perfect mirror image of each other. So you will see in the normal distribution, babalikan natin again, you will have the median, and even the mode and the mean at the center mismo. Okay? At the center talaga. Remember that the mean, median, and mode are measures of central tendency. Saan nakasentro yung ating collected data. That's the mean, the median, and the mode. And if you have exactly the same mean, median, and mode, most likely you will have a normal peak or a normal distribution. So here are the characteristics of normally distributed data. Number one, the data are unimodal. When you say unimodal, we only have one mode here. Because remember, there will be sets of data na bimodal or multimodal. Meron yan siya. Meron, di ba remember mode is yung score that has the highest frequency, meaning siya yung pinakamarami. Na pag nagpantay-pantayan siya, marami ka ng mode. But for a normal distribution, dapat unimodal lang. And then the distribution should be symmetrical. Okay, and then the frequencies decline steadily as we move towards higher or lower values without any sudden sharp or cut off. Kung nakita natin yung graph, ayan, pag bumaba yung curve, this one is just a smooth curve. Walang mga bumps along the curve na meaning nun may something wrong ka sa data na nakuha mo. So yan yung lahat ng characteristics of our normal distribution data. Now, aside from that, normally distributed data means about 2/3 of the individuals will have values within one standard deviation of the mean. Okay? So, kung atin itong hahatiin, class, so just like this one, lagyan mo pa siya dito. Okay. So, itong part na ito, ayan. For example, this one is just hypothetical ha. This one is one standard deviation from the mean. The mean is in the center. You compute for the standard deviation. And then, hanapin natin ang distance nila from the mean. Lahat dyan na nakasali. This one is 2/3 of the total number of data collected. Lang na wala yung aking pen. And then about 95% of the individuals will have values within 2 SDs of the mean or 2 standard deviation. If this is 1 standard deviation from the mean, and then almost 2/3 of the individuals will be here, belonging here. If you have another standard deviation like this one, ayan. So this one constitutes 95% of the total respondents. Meaning yung mga scores na nakuha nila is nakapasok talaga siya class sa graph. And then itong part na ito dito, the remaining 5% are just outliers, but nevertheless, you still have a normal distribution of data here. Okay? So yan yung ibig sabihin ng normal distribution. Paano naman yung positively skewed distribution? For a positively skewed distribution, the peak or the highest score will be found on the left side. Sorry ha, magbabalik-balik ako sa graph natin. This one is the positively skewed, and as you can see, the peak will be on the left side, and then the tail will be on the right side. So this is because the position of the mode is not really found at the center. Okay? So hindi siya nakikita sa center. Remember yung mode, pinakamaraming scores, and then we are talking about frequency distribution here. So kung saan nakasentro si mode, yan yung may pinakamaraming frequency. And nasa left side kapag positively skewed, and then meron kang parts on the graph na left side yung tail. So hindi smooth yung iyong curve dito. Pag start mo ng iyong graph, biglang umakyat and then bigla ding bumaba. That's positively skewed. And then this one is the other way around. So this one is still disproportionate wherein the scores are piling up at the right side. Okay? So balikan natin. So this one is the right side here. The scores are mostly found here on the right side of the graph, and then you will have a little remaining here on the left side. Ang sa positively skewed, the scores are piling on this left side of the graph. So hindi siya perfectly distributed. Okay? Yung mga collected data natin. For example, we gave IQ test to 100 people. So kung hindi normally distributed yung mga data mo, example 1 ito dito, itong meaning yan ha. Example 1, this is 100 na score here. Bibilangin mo kasi ilang tao ang nakakuha ng 100, ilang tao yung nakakuha ng 1. So kung negatively skewed ang iyong data, most of the individuals class, medyo mataas yung score nila. The scores are piling up here. Tapos meron kang mga individuals na medyo mababa yung scores. Okay? Kasi scores ito dito ay 1 to 100. Pag normally distributed, this is 1, this is 100. Normally distributed ang iyong data, yung mga scores nila, if this is 50 here. Ayan, nasa center talaga yung peak ng ating data. And then merong mga scores iba na nag-e-exist pero smooth lang yung pagbaba niya. Meaning, pantay-pantay lang talaga ang distribution ng data mo sa lahat ng scores. So like merong nakakuha ng isa na 1, may nakakuha ng isa na 100. Okay, ganun yung ibig sabihin nito. Okay? And then pag positively skewed, kung again the same set of data, nagpa-exam ka, so dito nag-pile up ang scores mo on the left side. So medyo mababa yung mga scores ng nakuha mo na sa mga respondents or sa mga participants mo. Merong mga matataas ang scores pero konti na lang sila. Okay? Konti na lang sila. So dapat, actually, ang target natin for statistics is this one. The data should be normally distributed so that we can really use the parametric tests in statistics. I will be discussing parametric and non-parametric tests sa mga next natin na mga lessons. Pero mauna muna itong frequency distribution kasi yung isang requirement to use the parametric tests in statistics is dapat normally distributed ang data. If it is not normally distributed, then we cannot use parametric test. Automatic, we will be using non-parametric test. To give you an idea, parametric test class examples niyan, t-test, ANOVA. Yan kasi yung mga pinakasikat, no? I don't know if you have encountered this test in your high school years. Pero alam ko yan talaga ang pinaka-common, t-test and ANOVA. They are both parametric testing. And for us to use them, kailangan normally distributed muna yung data natin. If not, then we cannot use the t-test and the ANOVA to process our collected data. We may use the non-parametric equivalent of the t-test and then the ANOVA, like the Mann-Whitney test and the Kruskal-Wallis test. So, tuturo ko yan lahat sa inyo. Para alam nyo din ang statistics class. Though this is not really a pharmacy subject, but you need this for research. You need this for research. And if you have plans to like pursue master studies or postgraduate studies, ano siya, gamit na gamit yung stat. Actually, personally, na ano ko lang ito, na-digest ko lang itong stat nung nagturo na ako. Nung nagturo na ako, I cannot even remember our lesson sa statistics during the college days. I don't know kung sino hitabo ato. Siguro nag-study lang ko for the sake na makapasa ko. Pero wala, siguro na ko siya na-absorb. So itong nagtudlo na ko, napilitan ko mag-study. So that is the thing na mauna siya ang reason nga nung nakabalo ko. Pero I'm not really a master pag-abot sa statistics, ha. Sa taman sa akong nasabtan, this is purely self-study for me. Mga daghan kay kog libro diri sa statistics kay nga ug sa nantaan. Okay, note, nasabi ko na ito kanina, positive or negative skewness is described as not normal distribution. And for those data that is not normally distributed, we have to use non-parametric test. Okay? P-test and ANOVA are parametric tests. So, pag nakita natin ay ang ating data are not normally distributed, please do not use P-test and ANOVA. Again, na-mention ko kanina examples ng non-parametric test. The man with me, type ko na nga lang. Ay, okay. Man with me, U-test, and the Kruskal-Wallis test. Actually, kung this one are used if you have questions like, is there a significant difference? Kahinumdum pa ba mo sa inyong research sa inyong senior high? Kay murag senior high gyud ang murag daghag research ba? So, kung na may question na is there a significant difference, supposedly we have to use T-test or ANOVA. Pero pag hindi pumasa sa normal distribution ang data mo, that's the time we use the man-Whitney or the Kruskal-Wallis. Pero pag ang question nyo, class, is there a significant relationship? We are determining if there is a relationship that is existing between the variables. Pag parametric test yan, we have to use the Pearson R correlation. Dili sad ko sure kung nakabati na mo ana or familiar siya sa inyong ha. Pero that's Pearson R for the parametric test for the testing of correlation. But if it is if your data collected is not normally distributed, then we have to use the non-parametric equivalent of Pearson R, and that is the Spearman-Rho correlation testing. So these are again examples of non-parametric tests that we can use to process our data, analyze and interpret the collected data, mostly in research. Okay? Actually, yan din yung ginagamit ng mga nagkakandak ng survey. Like ngayon, malapit na ang election. May mga organizations na nagkakandak sila ng survey. So, 'di ba nung prelim natin, nag-discuss tayo about sampling technique. So, 'di ba may sampling technique na tinatawag na probability sampling, wherein we are giving equal chance for all the members of the population to be selected in the study. Meron din tayong non-probability sampling na hindi lahat may equal chance. Ganun yung ginagamit ng mga, anong example ng mga nagkakandak ng survey? SWS, makita man yan natin sa balita, no? I'm not into news kasi SWS and what's the other one? The Octam, siguro Octa Research something. Sila yung nagkakandak ng mga ganyan. And then before sila mag-come up with that, kailangan muna sila mag-compute diba ng sample size. Pila na ba ang population sa tibuok Pilipinas? Like, pila na takaron? Di ko sure. Wala di ko balita. 80 million siguro. So like 80 million tayo sa Philippines, mag-conduct sila ng sample size, mag-sampling sila. Pero kung mahirapan kasi sila ma-achieve yung sampling size na required, minsan non-probability sampling na lang sila. So kung sino yung malapit doon, hindi ko kasi sure kung kasali ba ang Visayas and Mindanao when they conducted the research. So siguro yung iba doon ng probability sampling, andun lang sila, kung sa Luzon sila, doon lang din sila nag-conduct ng research. Kaya yung mga numbers na minsan na pag nagsuscroll ako nakikita ko, like sa presidential na ang tawag dyan, na race, di ba? May mga 50%, 40%, and so on. Hindi ko sure kung nag-probability or non-probability sampling ba sila, and then ilan yung kanilang respondents. Pero kasi pag hindi yan umabot ng like 50% of the total population yung kanilang respondents, hindi kasi siya magiging good representative of the whole population. So we cannot really conclude whether the results of their survey are okay or not, or maging representative ba siya pagdating sa election. Now, kung meron silang mga ipaprocess na data, yun kasi numbers lang, percent lang yung pinapakita nila. Pag meron na silang ipaprocess na data, like they want to see significant difference between the preference of the people coming from Luzon, Visayas, and Mindanao, they have to use inferential statistics na. Yung presidential race lang na number ng gusto kay Bongbong or gusto kay Lenny, descriptive statistics lang yon. Again, pag gusto na nilang mag-process ng data na like ano yung preference talaga, pwede yung division between Luzon, Visayas, and Mindanao, pwede din ang division, ang pag-divide nila is like, di ba murag na sila categories A, B, C, D, and E? E yung mga I don't know, I'm not into that. Basta may mga A, B, C, D, E na sila, dili lang dyan ko sure kung unsa ng A, B, C, D, and E. So if they want to test the significant difference between this group of individual or group of voters, they need to decide what statistical tool are they going to use. So before na sila makadecide whether parametric or non-parametric test ang himuon, they have to first identify the distribution of their collected data. If they have normal distribution, then they can proceed with the non-parametric test. Since maraming groups yon, A, B, C, D, and E, or Luzon, Visayas, Mindanao, tatlong groups, they may use ANOVA. Pero kung dalawang groups lang kasi yung kukunan ng significant difference, like babae and lalaki lang, that's the time you use the t-test. Si t-test and si ANOVA, parehas din silang parametric test. Parehas silang ginagamit to determine or to identify the significant difference between variables. It's just that t-test is used for two variables only. Like gusto ka makabalo sa significant difference sa lalaki o sa babae. Okay? Or kung daghan ang imong variables, 3 or more, like sinabi ko kanina, Luzon, Visayas, Mindanao, una natin yung difference ng preferences ng mga tao dyan, mga residents dyan. That's the time we use the ANOVA. That's the only difference. I just want to, though may discussion pa tayo dyan, no, pero ano na lang, para meron kayong idea. Kasi I believe you know t-test and ANOVA, pero I think libog mo kano saan na sila ginagamit. Okay? So pag hindi pumasok dyan, hindi normally distributed, we are going to use the non-parametric test. Na meron tayong ginagamit na formula for the skewness. Okay? Kasi mahirap naman mag-graph. Paano kung nag-survey sila sa buong Pilipinas? Tapos mga 50% ng population, pila ka milyon-milyon ang ilahang respondents. So kalisod mag-graph class ug ing-ani. Okay, and then kailangan nila identify kung normally distributed ba or not. So meron tayong formula to get the skewness even if we don't do or we don't make a graph. So this one is the formula. Skewness is equal to 3 times capital letter M. Capital letter M is the mean. And then minus the MD. MD is the median divided by the standard deviation. Okay, that's our formula again for the skewness. 3 times the mean minus the median divided by the standard deviation. Actually, marami tayong formula for skewness. May iba't ibang formula ito. Yung mga software din natin, like SPSS and the JASP, they also have, merong mga slight differences with the formula. So there will also be slight differences with the answer. Okay? But kailangan natin malaman yung how to interpret the skewness. Parehas lang kasi yung standard na ginagamit dito. Yung ating range. Like this one, if we have computed the skewness as between negative 0.5 and 0.5, the data are fairly symmetrical. So again, pag nag-compute tayo, meron tayong sets of data. We computed for the mean, we computed for the median, and also the standard deviation. Pag meron na itong tatlo, we can compute for the skewness. Tapos pag nakuha natin na skewness is between negative 0.5 and 0.5. Ang masasabi natin sa data, it's fairly symmetrical. Therefore, we can call it a normally distributed data. And thus, we can use parametric testing here. Okay? Now, if the skewness is between negative 1 and negative 0.5 or between 0.5 and 1, the data are moderately skewed. Okay pa rin naman kung moderately skewed. Hindi naman ganun ka-strict si statistics na straight lang jud kaayo. Pag naay gamay nga skewness, dili na gyud nato magamit si parametric test. This is still applicable pa rin siya for parametric testing. Ang hindi applicable for parametric testing is if the skewness is less than negative 1 or greater than 1. And we can interpret the data here as highly skewed. So it can be positively skewed or negatively skewed. When you say less than negative 1, that is negative 1.5, negative 2, negative 3, and so on. Pag higher than 1, syempre 1, 2, 3, 4, 5, higher than that, skewed na yung data natin, we cannot use the parametric testing. Before ako magbigay ng example of the calculation, you have here the kurtosis. This is another thing that we need to look into also with our collected data. When you say kurtosis, it will describe the shallowness or steepness of a distribution, and we have three types of kurtosis. Kasi baka yung nakuha mo na data is normally distributed but ang kurtosis iba. So ganito yung different types of kurtosis natin. The green one is called the leptokurtic or leptokurtosis, which is still normally distributed but it's thin. Okay? Payat siya. So parang nag-concentrate yung data mo sa gitna. It's still normally distributed though. Kasi pag hatiin mo yun siya, you will still have a mirror image of the left side and the right side. And then the red one is the mesokurtic. So that one, itong red one, yung tinatawag nating normal curve talaga. So I hope when we have our research and we collect our data, we can have a mesokurtic curve. Okay, mesokurtic curve siya. Normally distributed and a normal one, a bell-shaped curve. And then the platykurtic is still normally distributed but it's flat. Okay, it's flat. So again, ang gusto talaga natin sana for our collected data is normally distributed and mesokurtic. Actually, that ends this chapter. Do you have questions before tayo mag-try ng compute ng skewness and then mag-interpret later? Gusto bang itanong? Ma-apply lang natin ito kapag nag-ano na tayo class. Kapag nag-inferential statistics na talaga. You will have hypothesis testing next week. Panguta na? Sure na? Sure na good. Sige, let's try. I'll give you set of data. 10 lang ito para hindi tayo mahirapan. You may use your just. Actually, may skewness din sa just. Pero let's have first the manual computation. Example, you have this set of data. Okay. Sige daw. I'll wait for your answers on the chat box. 898-753-10-768. The first thing that you need to look, syempre, is the mean, and then the median, and then you have here the standard deviation. Ang hihintayin ko sa chat box is yung skewness. Hindi na ako magpapadraw sa inyo ng graph ha. Let's just see the skewness so we can decide whether our data is fairly symmetrical, moderately, or highly skewed. Should kayo mag-graph, daghan kayo atong i-graph. Bilis nila isa. How about the others? M is the mean. Mean, and then MD is the median. Naka-mute na ko. Okay lang, okay lang. Ibang formula kasi gamit nila doon. Pero gamitin muna natin itong formula here. Okay. So, nevertheless, parehas lang yung interpretation dyan. I-check daw nung answer ng iba. Ba't iba-iba kayang answer? I-check daw. Okay lang yung sa just, ha? You can use the just. You'll still get the same answer. I mean, the same interpretation. Ano naman sila lahilahin the answer? Let's wait for a few more minutes. Wala na maghabol na answer. Nag-load ang JASP. Matagal talaga mag-open ang JASP. Let's try first the manual computation. So we have the mean first. We have 8 plus 9 plus 8 plus 7 plus 5. 8, 9, 8, 7. Nalibat ko. Plus 3 plus 10 plus 7, 6, and 8 divided by, ilan na sila, 10. So this one is 3 times 7.1 minus the median. What are we going to do with the median? Diba, we'll arrange this one. 3, 5, 6, 7. Dalawang 7. Pati ano ha, pasabihan ako if meron akong nakaligtaan. This one is 8, tatlo. And then 9, 10. Tama ba? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then, this will be the center, right? 1, 2, 3, 4. 1, 2, 3, 4. So, 7 plus 8. Ako ba yung i-calculate? My trust issues. So, the median here is 7.5. So, we will use 7.5 here. And what is the standard deviation? Dugi kay kumahuman og mag-compute og standard deviation. Kindly check sa JASP. What's the standard deviation for the set of data? 2.025. Wait lang. Like 2.025. Ang iba, baka nag-round off. Like 2.03. Yung iba. Okay. Sige lang. Any slight difference, okay lang. Hindi talaga exact. I'm not really that strict with the decimal. 7.1 minus 7.5 is negative 0.4. And then this is 2.025. This is times 3. So this is negative 1. Ay, ano would na on? Negative 1.2 divided by 2.025. This is negative 0.59. Yeah, negative 0.59. So how do we interpret negative 0.59? Yung iba, ano answer? Negative 61. Okay. Okay lang yung negative 61. I think it's on the decimal, especially on the standard deviation. Like if you use 0.0248 or you rounded it off to 2.03, there will be really slight difference sa answer, but okay lang yan. Manual is negative 0.59, sa JASP negative 0.77, 0.63. So your answers are within the range except for those na positive ang answer ninyo. Bakit positive? Bakit positive? Okay, so ayan, negative 0.59 and then let's interpret this. Saan siya mahuhulog? Saan siya mahuhulog yung data natin? Negative dapat ito. How do we interpret this? Kaya muna yung tatanungin ko. Saan mabibilong? Like 0.59, 0.60, like negative 0.61. Skewness. If the skewness is between 0.5 and 0.1. 0.1. Bakit ano? Bakit moderately skewed? Ganito ha, pag highly skewed, less than negative 1. So that will be negative 1, negative 2, negative 3, negative 4. Tapos pag greater than 1, syempre 1, 2, 3, 4, 5, 6, and so on. So hindi yan siya papasok dyan. Anong i-answer natin? Negative 0.59. May range na lang tayo kasi yung iba nag-decimal eh. So like, siguro pinakamataas ng 0.65. Though sa JASP, it's negative 77. Okay? Now this one, if the skewness is between -1 and 0.5. So that is from 0.5, 0.6, 0.7, 0.8, 0.9, and so on hanggang mag-1 siya. Okay? So, ito, 0.5 to 1, gawin mo lang itong positive. Now, if the skewness is between -0.5 and 0.5 mismo, the data are fairly symmetrical. Wait lang, let me check this one. Kung tama ba itong ilagay ko dito. Skewness. Skewness. Saan ang values ko dito? Okay, ito yung values. Para dili ta mag-label. This one is coming from another book. Gusto ko yung isa. Okay. And then ito, parehas lang pala sila. -1/2 lang pala ito. Like -4, 3, -1, hanggang maging 0.5 siya class. Dito yan siya magfo-fall. So like kasama na dyan yung 0.1, 0.2, and so on. So what's our answer again? -0.59 to a range of -0.65. So most likely dito siya magfo-fall. So yung sets of data, yung binigay ko on the spot, yun siya. So hypothetical data, yun siya. The data, our data is like moderately skewed. So this is still applicable or acceptable for a normal distribution. Kasi though it's not really a perfect curve, pero at least hindi naman grabe yung skewness niya na nag-move talaga either to the right or to the left yung distribution of the data. So yun lang ang ginagawa to identify whether the data is normally distributed or not. And then later on, as we proceed with our computation or discussion sa statistics, we will be applying this to decide whether to use parametric test or non-parametric test. So again, I will not let you do or make a graph anymore. You just have to know the mean, median, and standard deviation for you to compute the skewness. And then after that, if you have the answer for the skewness, ang pinaka-importante is you know how to interpret it. As long as it's between -0.5 to 0.5 mismo. So that will be -0.4, -3, -1, hanggang mag-0 siya, tapos 0.1, 0.2, hanggang mag-0.5 na naman siya. That's fairly symmetrical. Okay? Pero pag mas mataas na values, like -1 to -0.5 or 0.5 to 1, the data is now moderately skewed. Pag mas mataas na talaga siya sa 1 class, ayun na, highly skewed na siya, and we cannot use parametric tests here. Sa JASP kasi, marami kasi tayong formula for the skewness. Merong mga slight difference. So as you can see, when you When you did the manual computation, the answer is negative 0.59, but for the just, it's negative 0.77. It's still acceptable. Meron talaga siyang magkaibang way sa pag-compute. Kagaya lang yan siya nung pag-compute ng sample class na we can use the Slovin's formula, others can use other formula and even the Rousoft software. Diba meron siyang slight difference. So ganun din yan siya sa skewness. Iba lang yung formula na gamit ni Just, but nevertheless, when we interpret the result, we will still get the same interpretation. When we did the manual computation, that's 0.59, negative 0.59, and that is interpreted as moderately skewed. If you use the Just, that's negative 0.77, and that is still that is still interpreted as moderately skewed. So okay lang. No problem. Mode ang nagamit. That should be the median. MD there is the median. Mean minus the median. 3 times mean minus the median divided by the standard deviation. So you really have to get the correct mean, the correct median, and the correct standard deviation for you to get the correct skewness. Kasi pag namali na kayo dyan, mean, median, and standard deviation, mali din ang skewness ninyo. Hindi mo na siya ma-determine whether your data is normally distributed or not. Now, paano kung nagkamali kayo, nakalagay sa data ninyo na it is fairly symmetrical? So, nag-parametric testing kayo when supposedly parametric test should not be used. Kasi ang totoo, skewed talaga ang data mo. So be careful with the mean, the median, and the standard deviation. Okay? Any question? The most important thing there is you know how to interpret the data. You have questions? This is the first one. Medyo konti lang yung isang chapter. Dito na ta makibaka sa pag magsugod na gyud tag inferential statistics. Questions or clarifications regarding this normal distribution?